Hey guys, I'm Will from Tested.
And I'm Norm from Tested.
We're here today, Norm, to celebrate the National Day of Makers with a whole bunch of exciting artists, makers, people who do cool stuff here at Autodesk in San Francisco.
So Autodesk, they make a lot of great software for 3D modeling, and it's compatible with things like 3D printers and CNC machines. And a lot of people don't know, there's a workshop here in San Francisco they've set up, and they've invited artists and residents to work on projects.
It's an amazing workshop. It's full of everything from the traditional tools that people have been using for hundreds of years, all the way up to the most modern CAD/CAM, crazy 3D printers, all sorts of neat stuff. But that's enough about that. I think we don't have that much time here, so let's just start talking to the artists and the makers and kind of find out why they do the stuff that they do and what makes them tick and all that stuff. Let's start with Paulo.
Yeah.
Paulo, are you there?
I am here.
Paulo, what kind of stuff do you do? What is your make?
Well, here at Autodesk, I've been working on a couple different projects. Most of them around kind of objects that are 3D printed, but also have some kind of motion or kind of poetry to them. And the two that I'd like to show today first is an actuator that I worked on with a couple other people here, which basically is a little servo, a PLA printed part, and basically with the servo controller I can kind of control the position of this piece. And this is 4 different artists that are here kind of came together to work on this project with an artist that just left. And it's a great example of getting together, collaborating, coming up with an interesting idea, and then realizing it really rapidly. And so that was one of the projects I wanted to show you. The other one, which may come up pretty well here on the screen, is what I call a string fountain. And basically, it's taking a loop of string and creating a way for it to kind of flow. Uh-oh. Like, how far away do I have to get from the camera from this to work?
Watch out for the power.
Yeah, exactly. Go ahead.
You're kind of a traditional artist, right? Engineer, artist.
Yeah, not painter, but more in the sculpture domain than in the painting domain.
And it seems like you're doing interesting things with motion in 3D printing, which most people think of as fairly static.
Yeah, no, and that's kind of what I've been exploring, is like, how do we add a little bit more to it? How do we move it to the next place? Because I feel like that now that the actual machines and the ability to print on the machines have become really affordable, and we're kind of starting to explore a lot of static objects and how we can interact with those. The next place is like looking at how do we add motion, how do we add kind of kinematic things to those particular pieces and get them out in the world and explore that domain as well.
We'll be back to you in a little bit, Paula. Let's roll over to Joe Martin. Jojo, are you there?
Yes, we're over here.
So what kind of you work with PCBs and LEDs and light installations and stuff like that. Can you tell us a little bit about what you're doing here at Autodesk?
So I'm a PCB designer, and a lot of that is really serious work most of the time. And I'm using my residency at Autodesk to try to explore things that I haven't normally done, like fine woodworking and robotics and interesting things like that. So I have a huge enjoyment of things that are whimsical. So one of the things I've been doing with robotics is a gimbal to stabilize a coffee mug automatically. So as the world moves around it, the coffee mug will stay perfectly stable. And we haven't had a good shot of it yet, but we have a conference room table upstairs in Instructables that's actually hung from the ceiling, and it swings back and forth. So this was whimsically designed to keep your coffee stabilized while you're in a meeting.
Well, so I mean, we see a lot of gimbals. Gimbals are really hot right now because people are attaching them to quadcopters and using them instead of Steadicams and stuff like that. This is a novel implementation. We're at the swing table right now. I could probably use the gimbal up here, it looks like.
Yeah, absolutely. We've tested it, and it does actually work up on the swing table. So, and the gimbal motors are super popular right now. They're coming down in price. They're used to stabilize, like you were saying, cameras on quadcopters. We're going to start looking at some bigger implementations of that. We want to stabilize a Weber grill on a sailboat. Is one of the things that we want to try doing with that.
Very cool. Next up, let's go directly to your left, to John Whitmarsh. John, what kind of stuff do you do here? Oh, there we go.
Are you?
Oh,
We have Scott.
No, you have Scott. I'm sorry.
Sorry, a little bit
Yeah,
confused.
let's talk about data crystals. You're doing cool visualization stuff and a lot of 3D printing work.
Great, yeah, my name is Scott Kildall, and I've been working primarily with looking at doing three-dimensional data visualizations. And I have a background in doing 2D data visualizations on the screen, but I thought here at Autodesk I have the opportunity to work with 3D printers. So I've created these things called data crystals, which look like that. And what data crystals are I work with open data sets and open data initiatives like the one San Francisco called the San Francisco provide a way for us to get data that's normally not publicly accessible and transform them in some sort of way. So I'm using code to transform them into three-dimensional models. So I write the code myself, create the 3D models, and then print them out at the printers here at Autodesk.
So what kind of data are you able to visualize with the 3D printers? Are you taking big giant data sets for retail places, or are you doing more kind of municipal stuff?
Right now I'm just doing municipal stuff. I'd like to expand it into other projects. So for the municipal data, it's mostly data that's accessible in a very easy way. I'm getting data that's things like retail data is not easy to get unless you work and partner with a company. But the municipal data is super easy. It's super accessible. So this one is crime data, and it's 35,000 data points of various incidences of crime in San Francisco over 3 months. And crime is bunched up in, it happens everywhere, so it's bunched up in this sort of thick, big crystal. Other crystals I've worked with and created are ones such as the San Francisco Development Pipeline, which is construction permits in San Francisco, and this has a more spread out kind of look to it. And so, and that has about 800, 900 data points. And primarily what I'm looking at are experiments in aesthetics versus sort of legibility. So if you want to get something that's super legible, you look at two-dimensional data visualization. But aesthetically, these kind of possibilities of looking at what can be done with 3D printing, this kind of work hasn't been done before, and this is stuff that you can only do here with access to these amazing printers and being able to prototype them and iteratively go back to them and repeat and see what you get.
Well, so I assume that over time you'll see interesting patterns emerge. As there's more or less crime, the sculpture's going to get bigger or smaller. Same thing for development, right?
Exactly. There are small patterns that will emerge, and so one thing I've been working on is making a key so that people can understand what the data crystals are all about. And once again, it's trying to figure out that balance between something that's totally beautiful sculpturally, but something that also has some amount of legibility in terms of being an actual data visualization that people can understand and relate to.
We jump back over to Palo. John, you're on the right over there. Now you were an artist in resident here at the part of the program, but now you're a little more permanent. What are the things you've done?
I tried to do a bunch of my work is based on like sculptural stuff that's sort of two-dimensional, inspired by nature, and so I used the residency to explore things that I couldn't do using traditional techniques. And one of them is this sort of dimensional piece that looks like broken glass, and you can see it kind of turns opaque when you tilt it. If you're looking straight at it, it just goes. You kind of see right through it. And this I cut on a laser machine, hand drew it in Illustrator first, and then laser cut it out of 3/8" plywood. And as you can, it's so delicate that you couldn't do it really any other way. So that was one thing that I did. Early attempts, I tried at metal, using real thin metal to try to braze it together, but it just started warping, and it's just totally impossible. So the residency was just to explore things that I couldn't do any other way using traditional methods, and a lot of experimenting.
You use a lot of kind of found materials and recovered materials, right, in your work, John?
Yeah, exactly. I've made some tables out of shipping pallets and salvaged wine barrels, and it's really a great thing to just take sort of stuff that nobody cares about and try to make something interesting and beautiful out of it. And it's free. It's just you find it on the streets, the pallets, and it's a challenge as an artist to try to take junk and make it look nice.
Let's go to Rachel next. Rachel McConnell is next, directly next to you. You kind of bring some whimsy into the stuff that you build.
I feel that that's a fairly common theme among artists, or especially the artists in residence here. Everyone likes to do something that's interesting and funny and maybe a little bit silly. It's a good way to explore the various different techniques and the various different ideas that you come up with. I will show you something that I consider whimsical. I made this a little while ago here on the 3D printers. I don't have to hold it up. This is a, it's breaking, it's very sad. The curl up, which is a creature invented by M.C. Escher. I don't know if you can see it well. I'll put it down now. It's actually got spines on the inside, and just when I came in here and was looking at what Paolo had, his bendy thing, I kind of want to like work with him and make this creature be able to curl up automatically by adding a stepper motor to it in the similar way that he just showed. So that's like a really awesome thing about being here at the Pier or just being in a community of makers, is that you see what they're doing and it can apply to your own work, and you can do all this cross-contamination of ideas, to use a whimsical word perhaps there.
That seems like an important part of the artisan residency program, is sharing information and kind of, you know, working with each other to make everyone's stuff better and more interactive and just cool.
Absolutely. Yeah, there's an awful lot that I have learned here, not just from the people who work here officially and are like teaching the machines, but also from the other artists in residence, because everybody has such incredible ideas, and it's just amazing to be able to like walk through and see all these really fascinating things that I would never have thought of, and be able to say, hey, can you tell me about that thing? And they always will, which is wonderful.
Now we also have Damas. You're connecting remotely, so tell us where you are and what project you've been working on.
Yeah, I'm here in Autodesk too, but I came from Brazil, so it's been also an experience work at Pier 9, just because I have access to all these machines and materials that it's normally in Brazil is very hard and very complicated to get access. So it's been amazing to have opportunity to prototype as much as I can. So I've been working in a robotic sculpture, like megaphones that point different directions, and I can screen share some of the images of the prototypes I've been doing. This is for an exhibition in Brazil. A moment, please. Yeah. I went to, yeah, so.
Explain a little bit about how your megaphone works, because it sounds
yeah.
Really, I want to actually.
So you can text messages from your smartphone, as well as send voice message through assistant we designed. Can you see the pictures?
Uh-huh.
Yeah, nice. So this is one of the first prototype I made. So the idea is to make a pen and tilt movements, so you can point different directions. It's going to be in a sail roof in the exhibition in Brazil. So it is the second prototype I did, and then the final one. So it was amazing because I could like test all the ideas I've been developing there, and I have some videos of testings. Let me show you, like this, like moving.
So you made an articulated megaphone, basically.
Yeah, basically, yeah. It's going to be in a roof, so people can text messages as well as send messages through a device on the wall. And I have some more pictures here. And here, another video. Someone sent a message, actually here. And you can see the shadow of the mechanism moving on the roof.
Yeah, yeah.
Yeah.
Well, very cool.
Yeah.
Let's go. Oh.
So. Yeah.
Oh no. So yeah, you've been working at Pier 9 and building this. It's installed now, right?
Yeah, it's happening in Brazil now, an exhibition, contemporary art exhibition. So we use the crowd, the voice of the crowd, so people can interact anonymously through this device and send messages through all the exhibition. Yeah, it was pretty cool, the experience at Pier 9.
Excellent. Well, thank you. Brian Allen, you are trying to make big stuff with small things.
Yeah, that's right. So I just started down here at Pier 9. We're super excited to be down here. I'm a co-founding member of Smith Allen Studio, and we specialize in architectural large-scale applications for 3D printing. So we are taking off-the-shelf consumer already available machines and through design, through iteration, through just printing and seeing how the machines fail and what you can actually do with those machines, seeing how we can design assemblages and systems that allow you to build very large structures. We're talking like room-sized structures using very small parts. Basically, we're rethinking the brick. So going all the way back to the most fundamental components in architecture that were built, using these components are things that have been around for hundreds of years, and they're made using machines that are hundreds of years old. With the advent of digital fabrication and the kind of machines that we have access to down here at the pier, we're able to really fundamentally rethink the way that we use construction, all the way down to the construction unit. So we're looking at things like this, which this is essentially a structural component that's ultra light, easy to print, and fits in assemblage. These aggregate together to create a structural part. So really looking at the ways that we can 3D print entire components, entire assemblages, and then looking at how those assemblages can fit into existing systems. So we foresee a future where 3D printing is ubiquitous. 3D printers are going to be everywhere, and we need to find applications for that. Architecture really can provide those solutions by saying, okay, you want a new ceiling in your house, you want a new wall in your house. Here are the designs. Go through online apps, customize it, and then print it out. So things like this is a ceiling piece we're working on. I guess it's very hard to see. You can see it from the side there, maybe, if I can get the light right. Anyways, this is a
kind of a textured, wavy surface on that's 3D printed. It looks like the kind of thing you really only make by 3D printing in mass.
Exactly. Yeah. Well, really something that you can actually only make using 3D printing, using digital fabrication methods that fits into an existing framework of construction. We see 3D printers as kind of a Swiss Army knife tools, something that compresses your entire shop down onto your desk and allows the designer to really leverage the power of a full CNC shop to iterate very quickly to get something much larger out.
So one of the people trying to make 3D printers more ubiquitous we have with us is Andrew Rudder. You're the CTO. You make 3D printers. You design them. Can you talk to us about that process?
Yeah, sure. So we, in this particular instance, so right next to me is an example of the machine that we currently ship. It's a sheet metal frame. It's a 3D printer. It's a filament type printer. So you take thermoplastic and you squeeze it through a very sophisticated hot glue gun, and you build up.
I think we're maybe losing Andrew's audio.
But not, sorry?
Oh, you're fading in and out there, Andrew.
Okay. So I am an engineer, and I designed most of this machine, but with a lot of help from all of the open source projects that came before me. But I'm not actually, my background is not engineering. I'm actually a lighting designer. And I bought one of the early 3D printers, and I built one of those printers, and I decided that I could probably do a better job. And after a number of iterations, people started offering me money. And so I said yes. And now we employ about 25 people, and we're building a bunch of printers here in the Bay Area.
Fantastic. One of the things that we talked about earlier with Paulo and some of the other artists is the transition of tools from tools that are variants of things that have been used since the industrial age, since the dawn of the Industrial Revolution, through the history as things have moved forward, and we're kind of entering a new age with the dawn of 3D printers and rapid prototyping machines and things like laser cutters and at more accessible prices and stuff like that. Paulo, can you talk about that a little bit?
Which part of our conversation are you referencing? Just kind of like how we imagine this evolving, or some of the challenges that we face, or where do you
opportunities that in this third wave of the the Industrial Revolution, where we now have the computational power and these tools, like what can we start doing that we never could have imagined before, and what the exploration process is like?
Yeah, and I think that, I think that the areas that are most interesting, at least to me, are the ones that you can't produce using traditional machine tools. And so things that have features or movements or parts that are kind of included inside of the parent piece, which couldn't really happen in the industrial age. Those are the kind of things that interest me. The other thing is like moving. I realize there's a phase that we kind of enjoy going through when we get our 3D printer. We go from like static objects, and then we print kind of traditional gears and levers, and then we eventually get a servo and we hook it up. But the things that are kind of fascinating to me are like looking at how nature has solved some of the problems of moving things around, and looking at the joints, like I don't know, the joints of ants or the joints of bees, and like taking those and actually 3D printing them and articulating them. I think that that'll be a really interesting place to explore, because it kind of, I don't know if, I don't want to say it closes the circle, but it takes something where we're making something, and then we're also thinking about how nature solves these problems, and we get into kind of this really interesting biomimetic space that I think will be really fun to see, how people explore it and what they do in that space.
Nature has gone through way more iterations than any individual person ever could.
Well, and I mean the thing that you touched on, and something that Brian's doing too, is building structures that only could exist using the new wave of tools, things, fused deposition printers, or whatever kind of 3D printer we're talking about, and the natural inclination when you get access to these new machines is to build the things you already know how to build, and it's only after you kind of learn the machine for a while. Are you seeing examples of things that people are only able to build after we've been able to use the machines for a while? Brian, Paulo, whoever.
I think what you see is like, you have the familiar and you're trying to learn a new tool, and so you take something that you kind of already have an understanding of, and you kind of print it and see what kind of resolution, what kind of what are the constraints of this new machine, because there's support material, there's a whole new set of like parameters that become part of your vocabulary really quickly as you start to kind of explore what these tools can do.
Cool.
Right. And I think part of the beauty of designing using 3D printers as an integral part of the building process is the artifact that they leave, this hand of the maker thing that really is a unique mark that shows how it's made. And as a designer's understanding, as a maker's understanding of the way 3D printers work evolves, the articulation of that mark evolves. So you can look at the things you would get just off the internet, and they're whatever you can make using an injection molder. But if you look at some of the really cool stuff, like what Scott is doing, it's really a great execution of what a 3D printer can do, something that could not be visualized any other way.
So for an artist like John or Scott or Joe, when you come into a place like Autodesk and you have all these new tools available for you, how does that inform the way you're creating art? Is the new process, are you trying to show off the process in your art, or do you have something in mind and you're looking for the right tool for that job?
I find with a lot of the things I'm trying to do here with our residencies, we try things in a couple different ways. So you may try doing something on the laser cutter, and if it doesn't work really well, you might go over and realize the shopbot's the best way to do it. Like, there are a lot of ways to do anything that we need to do. So I kind of use an iterative process and go through and try to find the best tool. And another thing that we're trying to do is, a lot of times with the Instructables that we're making, is figure out an easier, simpler way to do the things that we were doing, such that someone that doesn't have access to a really nice object 3D printer could do this on a MakerBot, or someone that doesn't have a CNC router could maybe do this with a table router. And we try to investigate all the different options so that other people can kind of join in on the fun of what we're discovering here.
Also, one thing I've seen and experienced myself is that even though you have access to all these amazing tools, you work with what you're really good at working with, your own tool set. You have a limited time as an artist in residence, like 3 to 4 months, So learning how to, for me, coming from a background of having an intense coding background, but not a great 3D modeling background, it's a lot easier for me to create 3D models with code than it is to create something new with Maya. And so I see this happening with a lot of the artists in residence, where they end up experimenting a little bit outside of their boundaries, but then coming back to the tools they're very strong with, and then pushing those boundaries just a little bit, but creating the new aesthetic forms with materials like that.
And Andrew, so the machines that you guys make at Type A, a lot of them told me are sent to education, to schools. How do you go about designing a 3D printer and the software that goes with that, so that it can be accessible and it can be something that kids can start exploring with?
In terms of the machine, it's the demands for most people are usually pretty simple. They want it to be reliable, and usually they want it to be as big as possible for the price range that they're paying. The software is actually where it's more important, and it was one of the really interesting things about Tinkercad. And the guys who originally created Tinkercad said that the key thing that they wanted to do was have a user interface that never surprised you, and so which is just a fancy way of saying that it's intuitive. And still, the biggest thing that always holds people back is design tools. And so they're getting a lot better, and they've gotten so much better in the last 5 years. But when people come, I like to give this. When people are coming to us and saying, "What can I make with a 3D printer?" the answer is, well, if I have to tell you what you're going to make, you're probably not going to use a 3D printer. The people who are buying 3D printers already can see in their head what it is they want to make, and so it's actually those software tools and figuring out the right tool for them to use, because some tools are better for some people than others, but just so they can pull that idea out of their head. Because getting it out of the machine is actually the easy bit. It's getting it out of your head and into the computer that's the hard bit.
Bits to atoms, right?
Yeah, absolutely. And it's the ethereal id stuff to bits that's always the biggest obstacle. And so the majority of people buying 3D printers are people who already have those skills.
So one of the big questions we get is, how do people get started? There's a perceived large barrier to entry to just making stuff, either because people feel like costs are too high for materials, or they need a big fancy shop like the one downstairs here. Rachel, where do you guys recommend people start? What's the good starting spot?
Well, like Paolo and Scott were both saying, start with something that you know already and work upwards from there. If you have like a huge set of complete unknowns that you're entirely unfamiliar with, it can be frustrating and difficult to really get a foothold on that. But if you do have, for example, data expertise and you can create a model in data, then you can start learning how to use the printer based on that. For myself, I started with some putting together pieces like even just Legos, right? So if you have an idea that you can make a physical object with any technique, then build on that technique to use some of any of the new tools that you may have access to.
We talk a lot about 3D printers, but there are so many different types of CNC machines here. I mean, there are machines that can make models out of paper. What are some of your favorite tools that you've discovered here, and what have you done with those tools?
My favorite is the water jet. I don't know if anyone has mentioned that yet, but that is a machine that shoots, I believe, 50,000 psi water with a bit of grit in it, and it can cut through stone, it can cut through inch-thick metal. I'm in process of using that right now to make a statue of a Tyrannosaurus Rex out of sheet steel. I couldn't bring that in to show you because it's going to be 8 feet tall. It won't fit in this room. But that was one of the machines that I was most excited about when I came to the pier, and that I'm most happy to have learned about. It does a lot of the similar things conceptually that a ShopBot or a laser cutter does, but it has a wider range of materials, and especially the heavy dutiness of the materials that it can work on.
We saw a lot of nodding from the people and the other folks in the Hangout when you talked about the water jet. Can we just go down the line, maybe starting with Jojo, and talk about just hit your favorites?
Yeah, definitely. WaterJet is for sure one of them. For example, the gimbal. I went from about an hour with the 2D CAD to send it to my business partner, who brought it into Inventor, made the cut files, and we cut that on the WaterJet in about maybe 20 minutes to do all of that. So it's definitely one of my favorites. The laser cutters are close second.
I mean, one of the things that Adam, someone who we work with at Tested, frequently says is that once you know how to turn a 2D material into a 3D object, whether it's cloth or cardboard or wood or whatever, then that skill transfers from material to material. Do you find that to be the case when you're using metal cut with the water jet, wood cut with the laser cutter?
I would say that's close. Yeah, the same skill set would be used for all of those. I personally am trying to do a lot of fine woodworking, and I'm really horrible at it. So it's a long stretch for me to say that I can work as well in wood as I can in metal, or at least as quickly. But yeah, definitely the same skills would apply.
What about you, Scott?
I'm a big fan of the meats and potatoes types of tools here. So I primarily use the 3D printers, the laser cutter, and then the simple tools from the wood shop. And like Jojo was saying, like this translation of materials into 3D forms can really go along a lot of different axes. I have a background as a metal fabricator, but I've also worked with wood. But really, any type of transformation of materials on a 2D surface can be made 3D. But when it comes down to looking at two-dimensional objects and making artwork as a graphic designer, it's always been a weak spot for me. As soon as it comes into a three-dimensional form, it's amazing. But I like working with tools that I can create objects with quickly. So the laser cutter is an incredible tool for that, because you can just cut stuff out in 5 minutes and then assemble it really quickly.
We also have a new artist that's just joined us. Francis, you there?
Yes, hi.
Hi, thanks for joining us, Francis. Now, you've done something really interesting that some people might have seen on the internet. You make fashion with 3D printers and CAD design. Can you talk a little about that?
Sure, yeah. We're most known for the collaboration we did with Shapeways and Michael Schmidt Studios for a 3D printed dress we made for Dita Von Teese. And since then, we've done fashion accessories. We're doing educational programs where we teach fashion designers how to work with these technologies. We're actually going to be doing one in San Francisco in early August. So sure, yeah. I mean, do we have time? I can show some images, or
yeah, if you have images, that would be great. I mean, one of the questions we get from people often is, what can I actually do with my 3D printer if I'm not a designer, if I'm not an engineer? And I think some of the stuff that you guys have done are interesting potential applications for people who may just want a 3D printer in the house to make accessories and stuff like that.
Sure. Yes. Let me pull it up. It's loading.
Oh, there we go.
So yeah, I mean, as far as making accessories in the house, a lot of the work we're using kind of industrial grade machinery, but we're also beginning to develop content for home 3D printers. This is the dress we made for Dita Von Teese. It's all 3D printed in a laser sintered nylon. Oh, let me jump ahead here. Sorry, I'm out of sequence.
Oh, I think we might have lost Francis.
Did you lose me?
No, you're back.
Okay.
Just when you started out working with 3D printers to make dresses and things like that, where do you even start with that? It's such a novel application for the technology. I wouldn't even know where to begin.
Yeah, I actually, I started really just interested in software. I was interested in drawing, and I was interested in what that meant for the designer to be able to draw. And then what happened was there was a gap between software and hardware, and I couldn't make the things I was drawing. And I was actually commissioned to do a bicycle rack for the city, the DOT. I started as an architect, and I then went into product design and eventually into fashion. But I couldn't build the proposal was the problem, because there was a lot of compound curvature. It was like some of the panelists were saying earlier, is that I was able to conceive of and model geometry and form that didn't really have any relationship to the language of contemporary industrial manufacturing. So I turned to 3D printing, which at the time was a prototyping technology, and it was really, really expensive. And it's only really gotten exciting in the past couple of years, where we're starting to see consumer-grade 3D printers where it's really viable to produce, objects like this on a 3D printer. I mean, this was, when I started working with 3D printing, I would fantasize about doing things like this. So it's come such a long way.
All right, let's continue on the line. I want to hear about your favorite tools. Let's go down. I think Who's next over there?
Thomas, maybe?
Yes, Donis.
Hello. Yeah. So yeah, WaterJet is my favorite too, because yeah, it's a finishing on cutting metal. It's amazing. But I've been working on the DMS 5X to milling some MDF and foam, and it's a pretty amazing machine. And I was using like the new tools like Fusion 306 and CAM from Autodesk. So it's decreasing the gap between the software and hardware. So from modeling, 3D modeling, it was super easy to go to the machine. That's a very fancy DMS 5X. So it's super nice to use those tools and don't have too much trouble and problems to do the CAM. So yeah, but also the Object 3D printer over there, it's pretty amazing. You just need an STL file and just go print, and you have this such nice object.
It's more like a 2D printer than what we think of as 3D printers at this point. We're getting there, right?
What is the question?
Oh, so I guess go on down. Oh, sorry.
Oh, I was saying it's like a 2D printer only in terms of ease of use. It's very easy.
Yeah.
I'm going to ask anybody else who has a favorite tool that's the WaterJet to list their second favorite tool from this point on. John, what about you?
Yeah, I mean, WaterJet, of course, is super versatile and it's very stable. Out of all the machines, it doesn't goof up a lot. Laser machine's really versatile. I just started TIG welding steel, and it's a really amazing, process. It's very elegant, just the way the TIG welding goes. That's a recent, thing for me.
Cool. Paulo, what about you?
I think it depends on the project. One of the things that I've learned is not to be too enamored with any particular tool, because there's like a workflow that you have to think through. And so it's what I've been doing lately is when I kind of conceive of a design, I try to figure out which particular tool will get me to that end result the quickest. And so I'll look at it and say, okay, I can basically WaterJet cut a couple pieces, assemble them, and TIG them together to get one particular thing. Or I could 3D print it, and it would take me 16 hours to do it. So it's just kind of a situation where I'm like, which one of the tools gets me to that iterative moment the quickest?
So you're maximizing the time available during your residency.
Well, not only that, but I feel like every time you get to iterate, you get to improve, and the quicker you can do. I mean, think about nature. Every time they get another generation of something, you get to make an improvement. And so, if I can get between this moment and when I have to show it, if I can have, double the number of iterations by changing the tool that I use, I almost always take that, because I feel like the work improves every time you get to rethink it and you get to hold it in your hand. And sometimes it's just simply starting with quarter scale and working through my ideas in quarter scale and then blowing them up to full size. But I think that to me, it's super important to kind of see the work go from pixels to bits to pixels to atoms as often as possible.
A lot of makers we talk to describe tools as being things that just cut the time it takes to build something, and it's all about the exploration of process. You guys are on the front lines of that. Where do you see these tools being in the next 5 years or so, and what do you feel are the barriers to getting more people access and comfortable with these?
You didn't direct
anyone want?
Who's going to take that one?
Cost is obviously a big barrier. The machines that we're talking about here, the WaterJet, the Connex 3D printers, they're very expensive machines. They're on the forefront, but at the same time, there are people doing really good work, such as Andrew, with bringing those costs down to something that an individual human or a small consortium of people can actually obtain and work with and learn and get those benefits.
And there are also models like TechShop where you can go in and learn and use the machines there. There are more service bureaus popping up now, so that if you do want access to an object, you can send the file to a service bureau, they'll print it and return it. There are a couple online, there's a bunch of them in most of the bigger towns in America. And so I feel like there's a couple different ways that you can approach, realizing your work.
Well, and hackerspaces too, right, Jojo?
Yeah, I was just about to talk about hackerspaces for sure. I've worked with Red Bull Creation for a few years. We've had some amazing hackerspaces contribute projects to that, and they're all over the country. I had no clue there were so many. And 3D printers are something that are just going to become ubiquitous. And as they become cheaper and cheaper, more and more places can afford them. And you can't have one in your house. There might be a hackerspace, a few miles down the street where you can print something. And we've got people, artists and residents here, a gentleman Andreas, that's working on 3D printing like prosthetics and like shapes, rigid shapes that can be used as casts for deployment in like third-world countries, anticipating that things like that are going to become ubiquitous in our life.
I think part of the issue, though, is that we're continuing to think about the kind of hackerspace model, and I mean, for this to really have the effect it's going to have, I mean, 3D printing could become incredibly disruptive technology, but I think part of the issue is it's not ubiquitous enough, right? And I think that we need to stop thinking about the kind of closed community of makers and thinking about like networks and infrastructures for distributing content. Because if it gets out of the makerspace and if it gets into the home and it does become this as ubiquitous as a personal computer, it becomes incredibly powerful at that point. And I think to just think about it as an isolated tool in the workshop is fine for us, but like what you really have is a kind of universal platform for production that can work with a wide range of materials. And there's a large percentage of consumer goods market that can be taken up by this tool. So it's nice to be making. We got to think about what we're making and how that content's distributed. And I think that's probably the biggest missing link right now. There's no real universal protocol for distribution. But even communication with printers is difficult from one platform to the other. So it makes it really hard to build a network and the kind of network that you really need for this to become what I think it can be, which is like a real Internet of Things. I mean, we talk a lot about that, but for that to actually exist, we need ways to talk to these machines.
Yeah, 3D printers are the machines that will build the Internet of Things. It really provides the backbone for all of these electronics platforms to be performative and to be networked and to interface with each other and really fill out the ecosystem. They're kind of, the first smartphone in the phone space. They are the portal into the physicalization of data and of network-driven systems. So for me here down at the pier, what I'm really excited about is the entire ecosystem. You have everything from like the Type A machines 3D printers down here, which are very consumer side, up to the M cores, to the Z core, and then all the way up to the objects. And then we can explore down here how those actually can interface with more traditional systems. Something like you would cut off of the water jet or the CNC machines, or run out of something you would build in the wood shop, to really fill the ecosystem and show how 3D printing is not something that only exists in hubs and nodes, but is really something ubiquitous, something that can be anywhere and can be printed in any source.
I agree, because I think at the heart of this whole maker movement is the idea that you're turning the factory inside out, right? You're taking the centralized model and you're decentralizing it, and that's the important thing here. I mean, that's what makes all this matter. It doesn't really matter so much what we're making; it's the accumulation of all this stuff and all these experiments. I mean, that's the kind of beautiful thing that's happening, I think.
If one of the questions we get a lot from parents is, hey, I was thinking about getting a 3D printer for my kid. What kind of projects and stuff, like, where, if you want to get a 3D printer for your 10-year-old, where do you start with them on the path toward making more and bigger and better things? It's just for the room. Sorry, I should have directed that at someone.
You know what?
Actually,
I think what you do,
about that a little bit.
you just give it.
Let's start with Paulo, and then we'll go to Andrew and Brian.
We all want to talk now. And I think that a 10-year-old kid is a perfect example. You just give it to them. You just give them an internet connection. You give them that device. You just get out of the way. I think that's the perfect age for getting something like that. It's easy to use, and sure, they'll start by downloading things that are very static. they'll print a bunch of Yodas, whatever. But I think that you're just going to watch something happen that'll just completely unexpected where they go. And as far as like how instructional you should be, I mean, I think it should be more descriptive than prescriptive. I mean, I think let them go through the space, ask them questions about what they're doing and why they're doing it, and just maybe guide them if they need to. But otherwise, I think you'll be really delighted at how quickly they pick it up, what they do, where they go, and why they go there.
Brian, anything to add? I think you're muted still.
Sure, there we go. So for, you know, Autodesk has pushed a bunch of very introductory programs like Tinkercad, the 123D Makes, the 123D Catch, that allow you to very quickly translate data into something that a 3D printer can start to use. So using free tools, easy tools like Tinkercad, the 123D suite, or even like SketchUp, to really just start thinking in the mindset of creating objects inside of a computer that are then going to be taken back out. That's a really successful place to start.
Andrew, anything to add?
I just want to sort of give an example and echo what Paolo was saying about just give them the tool. There was a wonderful quote from Chris Anderson who told us that he had helped his child design their own toy, and he would never buy a toy ever again. They're going to 3D print all of them because the child values, his daughter, I believe it is, values the toy so much more because it's her design. And one of our most exciting users is about 11, 12 years old, and he's designing different types of print heads to put on our machine, just because he wants to. And he's also, on the side, I give him some ideas, and now he's trying to build a 3D printer that might cost as little as $150. And it's just, I think all of us dream as children of having access to tools like this. This is why we're all so excited about it, because you'll think, well, when I was 10, if I'd had all of this, this would have been incredible.
The beauty of being a 10-year-old is that you have infinite free time, it seems like. And I guess on that note, wrap it up. Thank you, us. We've had a great conversation here today, I think. And of course, if you want to know more, you can check out the Google Plus page for Autodesk. Norm?
Yeah. Thanks for watching, and good luck on your rest of your projects.
Good luck, guys.
Thank you.
Bye-bye. Bye-bye.
Bye.
Thank you. Thanks a lot.
Bye-bye.
Bye.
Bye.